Aristotelian law of motion is flawed, as we shall see. However, it is a natural view that everyone would hold from common experience. Even a small child playing with a simple non-electric toy car on a floor knows intuitively that it needs to constantly drag the string attached to the toy car with some force to keep it going. If it releases the string, it comes to rest. This experience is common to most terrestrial motion. External force seem to be needed to keep bodies in motion left to themselves. All bodies eventually come to rest when what is the flaw in Aristotle's argument? The answer is a moving toy car comes to rest because the external force of friction on the car by the floor opposes its motion. Though to encounter this force, the child has to apply an external force on the car in the direction of motion. When the car is in uniform motion, there is no net external force acting on it. The force by the child cancels the force by the floor. The corollary is if there were no friction, the child would not be required to apply any force to keep the toy car in uniform motion. The opposing forces, such as friction and viscous forces, are always present in the natural world. This explains why forces by external agencies are necessary to overcome the frictional force to keep bodies in uniform motion. Now we understand where Aristotle went wrong. He quoted this practical experience in the form of basic argument. To get at true law of nature for forces and motion, one has to imagine a world in which uniform motion is possible with no frictional forces opposing. This is what Galileo did. The law of inertia. Galileo studied motion of object on an inclined plane. Object first moving down an inclined plane accelerate while those second moving up retard. Motion on a horizontal plane is an intermediate situation. Galileo concluded that an object moving on a frictionless horizontal plane must neither have acceleration nor retardation. It should move with constant velocity. Coming to the same conclusion involves a double inclined plane. The ball released from rest on one of the planes rolls down and climbs up the other. If the planes are smooth, the final height of the ball is nearly the same as the initial height, a little less but never greater. In the ideal situation, when friction is absent, the final height of ball is same as its initial height. If the slope of the second plane is decreased and the experiment repeated, the ball will still reach the same height, but in doing so, it will travel a longer distance. In the limiting case, when the slope of the second plane is zero, that is a horizontal, the ball travels an infinite distance. In other words, its motion never ceases. This is, of course, an idealized situation. In practice, the ball does come to a stop after moving a finite distance on the horizontal plane because of the opposing force of friction, which can never be totally eliminated. However, if there were no friction, the ball would continue to move with a constant velocity on the horizontal plane. Galileo thus arrived at a new insight on motion, and that had eluded Aristotle and those who followed him, the state of rest and the state of uniform linear motion, motion with constant velocity, are equivalent.